Okay, so as we have previously discussed in the last video, we were talking about correlation and finding a correlation between two variables. So that's what we call bivariate data. You're taking two variables and trying to figure out the relationship between each other. So for screen time, we could say, what's the correlation between screen time and your eyesight? Okay, so you can use a scatter plot to determine, your eyesight score in correlation with how much time you use on a screen. So those are two things that you could correlate to one another, and you can figure out their correlation. Is it a strong positive, strong negative, weak positive, weak negative, such as that. And you can determine the correlation coefficient based off of how strong or weak it is. So now we're going to talk about fitting a linear model to a scatter plot. So I'm sure, as you've already noticed, when you were creating these scatter plots, you could find a line or kind of see a line that would go straight through all of the points on the scatter plot. And we're actually going to find an exact fit, an exact line that will go through those so that you can find out some more information about that data. So you can find a scatter plot can be used to identify the correlation. We've already discussed that. But if the variables seem to be correlated, you can actually find something called a line of best fit. A line of best fit, okay? So let's do an example, and I'm going to show you today how to do this in Desmos so that there's not as much guesswork and it'll give you the exact variables that you need. So this table here we see is a relationship between two variables, and we're trying to figure out its correlation and sketch the line of best fit and then find its equation of the line. So first off, what we want to do is, taking this information, we want to create a table in Desmos with all of that information. So we're going to put in all of our x values. Then we're going to put in our y values, 16, 14, 11, 10, 5, 2, 3, 2. Okay, and something that I noticed a lot of people doing when they had their plots done is they weren't really drawn to a scale. Maybe it was the dots were super tiny and you couldn't see them, or the histograms when you did that on the restaurant menu task. So what you can actually do is, if you see this button over here that says Zoom Fit, you can just click that and it will put it in a scaled picture for you. Okay, so that right there is our scatter plot, and you're probably already noticing some things. Well, first of all, as our x increases, what do we notice about our y? Well, I'm noticing as x increases, so I'm going along the x-axis, my y goes from 16 to 14 to 11 to 10 to 5, etc. So my y is decreasing. So as my x increases, my y decreases. So that means that this data is negatively correlated. Okay? So now what we're going to do is we're going to use a tool to find the line of best fit. So we're going to click up here where it says to the plus sign, add item, and we're going to do f of x expression tool. And we're going to enter y1 and a squiggly line. Having a hard time finding the squiggly line today. Okay. M being our slope, x1 plus b. This is going to give us a line of best fit for this set of data. Now, with that, we're going to be able to find an equation of this line. So what we first want to do is we want to choose 2 points on this line. So let's just find a point. I see one here. Let's see if we can find a... That's fine. We'll use So you can actually choose any line or any point on this line. Trying to get us to some whole numbers, but if we can't, that's okay too. Okay, so let's just select a point on the line. So we'll select this one being 0, 17.8, and the other point being, let's just go down here. Let's go to 8.10. Okay, so these are 2 points on this line. And we're going to use those to be able to find an equation of this line of best fit. So let's use those points to find the slope. So we know that the slope is the change in y over the change in x. I'm actually going to show you that here. Okay, so the change in y and the change in x. Well, our y values are going to be 0 minus 17.8, and that may be a negative number, that's okay too, and 8 minus 0. Well, 0 minus 17.8 will be negative 17.8 over 8. This is going to be our slope. Okay, so let's use a calculator to find that. So negative 17.8 divided by 8 should be negative 2.2. We'll say it's negative 2.2. So this is our slope. Okay, so after we have found the slope, we're going to use the point-slope equation to find the equation of a line that models this data. Well, we've already found the slope. So, and I've given you the equation for point slope so that it'll be easier to find. So that is y minus y1 equals the slope times x minus x1. I'm noticing my pen needs to be a little bit bolder. Okay. So let's use this information. Well, y minus y1. So y minus y1. So we're going to say 17.8. This is x1 and y1, x2, y2. Okay, so y1 would be 17.8. We found our slope, so that is negative 2.2. Then times x minus x1, and x1 was 0. Okay, so this is your point slope form. And you can actually simplify it down to make it a y equals mx plus b type of equation. So let's do that. So y minus 17.8 equals, we'll need to distribute that negative 2.2. So it'd be negative 2.2x. And then anything times 0 is just going to be 0, so you're not going to add anything in onto that. Now all we have to do is move the 17.8. So we're subtracting, so now we're going to add it so that it cancels. Okay, so we have y equals negative 2.2x plus 17.8. So that is our equation of that line of best fit. Okay? So we have found the line of best fit. So using this equation, how could you estimate the next point on a scatter plot? So let's look back at this graph on Desmos. So let's say, I don't know, we wanted to find out where the line would go here, okay? So we're trying to see if our x is 6, then where the next point would be. So you can actually just plug that back into the equation. Now, the information after you've plotted it, Desmos gives you all kinds of information. You see this r squared, we're going to ignore that, but the r is actually going to give you the correlation coefficient. And we remember negative 0.9, that's closest to negative 1. And negative 1 and positive 1 are very strong correlations. Because it's negative, it would be a strong negative correlation. Okay, it also gives you residuals, and we're not going to worry so much about that. But then the perimeters, we already found these perimeters when we found the equation of our line of best fit, but that m is your slope, and that b is your y-intercept. So let's look pretty quickly at what we just did when we found our line of best fit. So you actually found your slope being negative 2.2 and your y-intercept being 17.8. So you could just look at these parameters and find your line of best fit. Okay? So that is something that does. And if we notice here, this information gives us a strong negative correlation based off of this correlation coefficient. Okay? And the correlation coefficient was negative 0.9. All right. So that answers all of this for finding the line of best fit of an equation and finding the equation of that line. Okay, and if you need to refer back to this to help you discover how Desmos helps you do that, then please do so. Do not hesitate. All right, you guys have a great and wonderful day.